Okay, so they're talking about rational functions now in your class, and they're asking for you to graph key information like where the asymptotes are and where it hits the x-axis. So this video is going to go through all of those things today, but mostly focused on the horizontal asymptotes and why they do it mathematically, and at the end we'll do a little mnemonic to help you remember. So let's start with the two easier ones. So after you do the factoring on the top and bottom, and you've simplified everything down, then you're ready to do the vertical asymptote. So a vertical asymptote forms when the function does not exist. We break it, aka we divide by the zero. So what you need to do is just look at the bottom of your fraction and say, okay, when for which x does that make it 0? So in this case, if x is 6 or -2, then we would be dividing by 0. So that means that we're going to have a vertical asymptote at those two places. Okay, and then next we want to know when does it cross the x-axis. Now that normally happens in a function when the function's just 0. But like we just said, we can't really divide by 0, so really we just need to focus on when is the top 0. So in this case, it's going to cross at x is 3 and when x is -5. Okay, so that's simple enough. Now let's go on. Oh, and this demonstrates that this is true with this function. Okay, so let's go on to the horizontal asymptote. So if you think about it, when it's a horizontal asymptote, that means we're asking, like, what does it do in the long run? Is there a ceiling or just some number that the function is going towards in the long run? So the best way to look at that is look at the highest degree on the top and the bottom of our fraction. Okay? And we're going to see which one has the higher one, because then that will tell us how the function is growing or not. Okay? So for example, if it's higher in the bottom, then that means the bottom's getting bigger and bigger than the top, so we're getting a smaller fraction, aka we're going closer to 0 every time. Alright, so if the degree is higher on the bottom, there is an asymptote at y equals 0. Such as in this case. Okay, see, the degree on the bottom is 2x squared, and the one on top is just x, like x to the 1. So this one will go to 0. Okay, so then if the degrees on the top and the bottom are equal, say they were both x squared, like in this case, then it's almost like in the long run those x squares cancel each other out, and we are only left with the 2 and the 5. So there will be a horizontal asymptote at y equals 2/5 in this case. Okay, and then if the degree is higher on the top, it does what you think it should. It should just keep on growing, right? Just goes on to infinity. So that means there really isn't a horizontal asymptote in this case. Okay, and with this, sometimes there is a specific case. You may have heard of an oblique asymptote, and that's just when the degree on the top is just one higher than the one on the bottom. Say it's x cubed over x squared. So that means, let me show you what I'm talking about. That means that it's going closer and closer to this line here. Okay, and it's not a horizontal or a vertical one, so in this case you wouldn't need to do a horizontal one, but if they ask for it explicitly, then you need to find the equation for this line. And how you do that is you just do long division with your rational function. So take the top divided by the bottom. Okay, just do long division, and what you get is the answer. You don't need to worry about the remainder. Okay, so that's just the special case with the top. Okay, so now that you know the mathematical reasoning behind these, let's also do a kind of visual to help you remember these as well. So what you're going to do is you're going to draw a snowman, and its shape is based on where the higher power is. So if it's bigger on the bottom, then your snowman looks like a big fat 0. So it's going to y equals 0. If the powers are equal, then it's just like you're circling those coefficients on the leading term. Okay? And then if the power is higher on the top, then your snowman topples over and looks like an infinity sign, aka there's no horizontal asymptote. And then finally we have that weird case where the head of your snowman is just one bigger on the top, so you just have that urge to slice the snowman in half, okay? So that creates your diagonal oblique asymptote, and you're dividing your snowman, you're dividing your rational expression using long division. Okay, so that covers all of the key information that you need to graph rational expressions.